to welcome everyone to the first webinar, as I said, sponsored by the fourth year students. To start the program, let us ask the Lord first for His guidance and blessings through this prayer and meditation. Okay, again, good afternoon to everyone. So for today, we will have a short run-through of our activity. So I'll be giving a short welcome note. I'll be showing the video teaser, the teaser video rather, prepared by the sponsoring group. And then I'll move to the introduction of our guest speaker, Mr. Christopher T. Carpio. And then as he said earlier, we will have enough time for Q&A. I'm sure that Sir Chris will be very much willing to answer all your questions later.
Yes.
Okay? So before I formally open the program, let me play this video created by the sponsoring group, just to tease you of what to transpire in the next hour or so.
See how Americans are being impacted by the COVID-19 pandemic. Weekly jobless claims coming in above estimates at 1.3 million.
Ramboy Panganiban says his family is lucky if they are able to eat 3 times a day.
Okay, so that's our topic for today's webinar, the future of machine learning and AI amidst the COVID-19 pandemic. As we all know, these two technologies are the most trending technologies related to intelligent systems. Big word, no? But that could be simplified by Sir Chris later on. The COVID-19 pandemic has directed the attention of IT experts all over the world to perfect the said technologies. And to all our graduating IT students here, as well as our lower classmen, these are the areas that you might want to explore. And that's why we've invited somebody who can confidently discuss with us the various aspects of these technologies. I am pretty sure that this will be a very fruitful afternoon for all of us. Okay? Our speaker today, as I said, is Mr. Christopher Tan Carpio. He has 23 years IT industry experience and has been engaged in several different roles, from site management, infrastructure, operations management, stakeholders management, customer support, and quality, software development, project management, and people management from almost all business aspects. I am honored to present our guest speaker, who's not just here to share with you his expertise, but to inspire you as well. Let us welcome Sir Christopher Tan Carpio.
Thank you, guys, and thank you, Ma'am Lori, for that wonderful welcome note. So let me now start. So yeah, I'm very excited to discuss about the topic that we have today, which is the future of machine learning and artificial intelligence amidst the COVID-19 pandemic. Yes, what Ma'am Lori said, so currently I'm connected with one of the biggest financial technology companies in the world. So also in one of my past times that I do, or in my free time, I also have launched like a blog. So as you can see down below, so it's called the Corporate Slave PH. So it basically discusses about life in the corporate world, like what to do in interviews, what to do in in hiring, or if you're course, after graduation, what career path you want to take. So I provide tips and tricks on how to navigate through the corporate world. But yeah, enough about me, and let's move over now to the topic at hand. So, okay. So AI. Okay, so how is artificial intelligence and machine learning really shaping the future? So in the next slide, I have a small clip about one of the companies that is spearheading AI. Just gonna share a little tidbit about how
Without
AI is.
AI, many of the other things that we think about as emerging technologies really cannot take place. For example, IoT devices collect data, but without running AI over that data, you're not getting any benefits. Autonomous vehicles need AI to actually be able to drive on the roads. It is impossible, if a business wants to survive, for it not to have a plan to understand AI and deploy AI safely, ethically, and responsibly. The platform's core activities are around the governance of this technology so that we can accelerate the benefits whilst also considering the challenges: privacy, accountability, transparency, bias, and safety. And the purpose is really to think about what are the big issues, what are those global issues in artificial intelligence that really require something done in the governance area so that AI can flourish. And so all of our projects address both the benefits and seek to mitigate those challenges. So we have a project called Empowering AI Leadership. The idea behind this is that companies do not, on the whole, know enough about artificial intelligence and the impacts for good and ill that AI might have on their company. We have created 12 modules which help boards of directors to really have proper oversight of the use of artificial intelligence and be able to guide the C-suite to think about putting in the relevant guardrails for the use of AI. All the work that we do, whether the work is led by companies or whether the work's led by governments, it's always multi-stakeholder. It is really important that we have this global conversation about the use of artificial intelligence, as well as for countries themselves to look at how they're going to use it and how they're going to grow their own AI economy. It's really difficult to regulate. So we're very much advocating this sort of soft law approach, thinking about standards and guidelines rather than looking to regulation. The forum has this unique opportunity to work with everybody across the globe. It's that richness of the multi-stakeholder community that is going to be able to tackle some of the challenges that we have in really constructing the framework for the 21st century.
Okay. So yeah. So basically, World Economic Forum is one of the companies that are spearheading in AI. So yeah, before we proceed about like how AI and machine learning shaping the future, okay, let me first discuss, of course, in layman's, like what is artificial intelligence and what is machine learning. So AI is a simplified problem-solving process for humans. So it enables software to perform tasks without being explicitly programmed. So it also includes, of course, neural networks and deep learning. And it is bigger concept of machines being able to perform tasks the way we would consider it done by them. So in the next slide, I'll also do a little, it's a bit about what AI is.
Artificial intelligence is techniques that help machines and computers mimic human behavior. It's like a Russian nesting doll. Artificial intelligence at the highest level is the device being smart. how it becomes smart under the hood then is the next layer of machine learning, which are the general techniques or a variety of techniques that are used to make that device smart. And then there's a further subset of algorithms or techniques called deep learning. Artificial intelligence is going to be used in everything. So I'll give you two examples. If a car has intelligence built in, if it can see the world, so looking at what's on the road, looking at you as the driver, and being able to anticipate and course correct when something goes wrong, something jumps into the road. Autonomous vehicles of any kind are not going to be autonomous without artificial intelligence. In the medical field, new treatments that'll come from the analysis of reams of data to detect cancers and diseases. Today, machines are smart, and they're smart because of AI. But AI still has a dependency on us, people. We're making it possible. The next phase is when artificial intelligence is able to walk on its own. Companies like Qualcomm, if we do our jobs right, and if artificial intelligence is done right, the actual implementation is totally transparent to a consumer. But what they end up with is devices in their world that are more than utilities. They're actually experiential, and they will make your life easier, more exciting. This is truly a transformational technology. It's that big.
Yep, agree. So yeah, it's that big. As you can see, like companies like Qualcomm is looking into like LiDAR technologies for autonomous vehicles. So yeah, so that's the power of AI for you. So moving along on the next slide. So now that I've discussed artificial intelligence, I'll be moving over to machine learning. So basically, in a nutshell, machine learning is an application of artificial intelligence that enables machines to access data and let them learn to perform these tasks. So it uses algorithms and allows systems to find hidden insights without being programmed. So in the next slide, I'll also tell a bit about machine learning as well.
What is machine learning? Let's say we have a picture and we need a program to tell us if there is a banana in this picture. Traditional programming requires human to define a set of instructions to recognize a banana. This would require tons of code and leave plenty of room for error. With machine learning, we just need data, a tons of data to be precise. Lucky for us, thanks to the internet and smartphones, we have a tons of data. In machine learning, instead of following hard-coded instructions, program can learn from data or adapt its behavior according to experience. We can divide machine learning into three broad categories: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we need to provide a dataset, labeled samples of training data. The program will analyze them and should be able to correctly determine labels for new data. This technique is used, for example, in speech recognition or by YouTube to recommend you a video. Unsupervised learning is used when we have unlabeled data. The most common unsupervised learning method is cluster analysis. It's able to find hidden similarities, patterns, or groups. Unsupervised learning methods are used, for example, in bioinformatics for genetic clustering or face recognition. And last but not least, reinforcement learning. This technique is like teaching your dog new trick. You provide the program feedback in form of reward and punishment, based on which it can determine ideal behavior or strategy within a specific context. This can be used to teach the program to play poker or control robotic arm. Thanks for watching.
So why is AI and machine learning important? So basically, big companies like Google, Facebook, Twitter, so they bank on artificial intelligence and machine learning for their future growth. So they need these things to be able for them to be competitive in their respective markets. So yeah, with the growing volumes and varieties of data available, the need for the computational processing is becoming vital so that we can provide deep-rooted information which is now like very cheap and easily available. Now, of course, with the help of AI and ML, it's possible to automate models which can analyze bigger, complex data and return more fast and accurate results. Okay. So now, what is the main difference between AI and ML? So AI is a bigger concept to create intelligent machines that can simulate human thinking, capability, behavior, whereas machine learning is an application or subset of AI that allows machines to learn from data without being programmed explicitly. Okay, so what's the difference? Okay, so again, AI system does not require to be pre-programmed. Instead, they use algorithms which can work with their own intelligence. So again, AI can be classified into these three types. So currently, we're in the generation wherein there's weak AI and general AI. But the future holds true for strong AI, wherein AI can now have a consciousness, is sentient, can think, can decide. So that's where we want to be heading at. So it can mimic human behavior and human thinking. So that's the future. But it's happening right now. So to discuss about weak and strong AI.
John Sewell put it as, the mind is to the brain as software is to hardware. Now, there exist two opposing arguments for this. The first is strong AI. According to strong AI, a strong AI should be able to reason, solve puzzles, make judgments, plan, learn, and communicate. But there is more to being conscious and being intelligent. Strong AI should have consciousness, to have subjective experience and thought, self-awareness, sentience, the ability to feel perceptions or emotions subjectively, and sapience, the capacity for wisdom. So how do we test this? The Turing Test. The Turing Test is a test of a machine's ability to exhibit intelligent behavior equivalent to, or indistinguishable from, that of a human. To pass this test, a panel of judges must each hold conversations with real people and a computer, unaware of which is which. If the judges are unable to distinguish the computer from the people, then it has passed the Turing Test. The second argument is weak AI. According to weak AI, computers can only simulate the mind. They may simulate real intelligence, but however good they are, they cannot create a real mind or a real consciousness, but only as if consciousness. John Searle supports weak AI with his famous Chinese room thought experiment. Suppose a man is sitting in a room with instructions on how to respond to a certain Chinese conversation without any actual translations. A Chinese speaker outside the room passes notes back and forth under the door. As far as the person outside is concerned, they are holding a conversation with somebody fluent in Chinese, thereby passing the Turing Test. Searle claims that the person inside the room doesn't really understand the conversation, simply simulating it. As he put it, syntax does not suffice for semantics, and the Turing Test is simply not a good measure of artificial intelligence.
Okay, so there you have it. So that's discussing about weak AI and of course strong AI. So moving along to the next slide. So what's the difference between AI and ML? So for ML, our machine learning, so basically it's a subset or subfield of AI. So which enables machines to work on algorithm which learns by its own by using lots of historical data, so without being explicitly programmed. Now, it can be divided into the three types mentioned. So this is supervised learning, so reinforcement learning, and unsupervised learning. So to elaborate on that, so I'll have another bit on the next slide for supervised and unsupervised learning.
Machine learning is a type of AI that mimics learning and becomes more accurate over time without being explicitly programmed to do so. Think recommendation engines, a common machine learning application which gives you more tailored ads the longer it observes your clicking habits. The two most common approaches to machine learning training are supervised learning and unsupervised learning. Supervised machine learning requires a data scientist to train the algorithm with labeled inputs paired with desired outputs. For instance, a shape with 3 sides is labeled as a triangle. The goal is that the algorithm can eventually take in new inputs and independently predict the correct label for the data. Supervised machine learning is ideal for binary classification, multi-class classification, regression modeling, and ensembling. Unsupervised machine learning does not require a data scientist to provide labels and corresponding outputs. Instead, the algorithm sifts through unlabeled input data and identifies patterns that it will use to group data, like how many sides a shape has. It's unsupervised because there are no teachers and no right or wrong outputs. The algorithm is responsible for analyzing the underlying structure in the data. Unsupervised learning is ideal for clustering, anomaly detection, association mining, and dimensionality reduction. Supervised learning is the more common of the two machine learning techniques. It provides accurate results, but can be complex, time-consuming, and expensive to compute. Unsupervised learning is less complex and takes place in real time, but is also less accurate.
Okay, so there you have it. So moving along, thank you for answering. So moving along, so here are the key differences between AI and ML. So number one, of course, is AI is a technology which enables machine to simulate human behavior. And of course, ML is a subset of AI which allows machine to automatically learn from historical data without programming it explicitly. Now, the goal of AI is to make a smart computer system like humans to solve complex problems, while the goal of ML is to allow machines to learn from data so that they can give accurate output. Now, in AI, we make intelligent systems to perform any task like a human. But in ML, we teach machines with data to perform a particular task and give an accurate result. Now, machine learning and deep learning are both subsets of AI, while deep learning is a main subset of machine learning. Now, AI has a wide variety of range and scope, while machine learning has limited scope because it only depends on data or past data. So AI is working to create intelligent systems which can perform various complex tasks, while ML is working to create machines that can perform only those specific tasks for which they are trained on. Now, AI system is concerned about maximizing the chances of success. However, for machine learning, its mainly concern is about accuracy and patterns. Now, the main applications of AI are, of course, Siri, customer support using chatbots, expert systems, of course, online game playing where like there's matchmaking or you're playing against an AI, so intelligent humanoid robot, and etc. Now, for the main applications of machine learning, so these are the online recommendation systems or Google search algorithms, or like auto tagging friend suggestions based on the pictures. So as you can see, like in Facebook, like, or even in your phone, like if there's a picture of somebody and it appears a lot, it suggests that this person is, especially if it's in your contacts, it suggests to tag this person as such. Okay, now on the basis of capabilities, AI can be divided into three types, which are weak AI, general AI, and strong AI. Now for machine learning, it's also divided into three main types, which are supervised learning, unsupervised, and reinforcement learning. Okay, now we're to start with AI, so here's a bit about that one.
So when I talk with executives, the first thing is really to listen to the executive, listen to the client, find out what their problem is. And in the world of machine learning, sometimes they need a little coaching. So I say, well, are you trying to solve a detection problem? Or are you trying to solve a prediction problem? Or is it more of an optimization problem? But then it has to essentially move from that point to really hard discussion of what kind of data do you have? Are you talking databases? Do you have call center records? Do you have emails from customers? Do you have web logs? What is the data source? And so understanding the data sources and the business requirements sort of move you toward starting to talk about a solution. I really like this philosophy of think big but start small, because so many times we think big and then start big, and that can lead to quick failures. So one of the mantras in data science is what they call fast-fail mentality. Building a quick model, see if it works, and improve on it, and iterate and build it up to the more complex model if necessary. What's the minimal viable product where we can declare a victory and go from there? So let's start small, but think big.
You need to be able to do a fast-fail mentality, because there's a lot of different things, a lot of different variables that is an input of machine learning. Okay, so moving along. So AI, ML, deep learning, and beyond. So basically, artificial intelligence brings with it a promise of genuine human-to-machine interaction. When machine becomes intelligent, they can understand requests, connect data points, and draw conclusions. They can reason, observe, and plan. Now, let's say given this, like planning to buy something, so your device will automatically offer items and stores that carry that item closest to where you currently live. So for example, let's say you broke your chair and you post that broken chair on Facebook. Like in a couple of minutes, you will now see ads in your feed about ergonomic chairs, who sells ergonomic chairs, or even like if you like the ube pandesals or those type of things. So even if when you're just planning or just posting about it, well, the device already gets your data and is suggesting things that you can buy. Okay, now for example, like you're planning since we're in the pandemic, so if you're planning an online birthday celebration, your bot like an Alexa will help you with sending invitations, scheduling food deliveries to the people attending online, and of course confirming your attendees. And on the business side of things, so if you're planning like a direct marketing campaign, so the AI assistant can segment your customers into groups. For example, like demographics, like the 18 to 25 years old female gamers, what do they usually want? So like the gaming chairs, or like for male athletes between the 25 to 30, so they would want like new shoes, something like that. So basically, your assistant AI can make targeted messages so that you can increase response rate when you are doing a marketing campaign. Okay, or that. So yeah, so let's see concepts driving machine learning.
Hello everyone, welcome to this tutorial by Simplilearn. In this video, you will learn about an interesting machine learning topic, that is supervised versus unsupervised versus reinforcement learning. Let's discuss each of them in detail and understand when to use these algorithms along with their applications. Now, there are a number of algorithms used in the field of machine learning to solve complex problems. Each of these algorithms can be classified into a certain category. So the different types of machine learning algorithms are supervised learning, unsupervised learning, and reinforcement learning. Now, let's look at the definition of each of these learning techniques. Supervised learning uses labeled data to train machine learning models. Labeled data means that the output is already known to you. The model just needs to map the inputs to the outputs. An example of supervised learning can be to train a machine that identifies the image of an animal. Below you can see we have a trained model that identifies the picture of a cat. Unsupervised learning uses unlabeled data to train machines. Unlabeled data means there is no fixed output variable. The model learns from the data, discovers patterns and features in the data, and returns the output. Here is an example of an unsupervised learning technique that uses the images of vehicles to classify if it's a bus or a truck. So the model learns by identifying the parts of a vehicle, such as the length and width of the vehicle, the front and rear end covers, roof hoods, the types of wheels used, etc. Based on these features, the model classifies if the vehicle is a bus or a truck. Reinforcement learning trains a machine to take suitable actions and maximize reward in a particular situation. It uses an agent and an environment to produce actions and rewards. The agent has a start and an end state, but there might be different paths for reaching the end state, like a maze. In this learning technique, there is no predefined target variable. An example of reinforcement learning is to train a machine that can identify the shape of an object given a list of different objects such as square, triangle, rectangle, or a circle. In the example shown, the model tries to predict the shape of the object, which is a square here. Now, let's look at the different machine learning algorithms that come under these learning techniques. Some of the commonly used supervised learning algorithms are linear regression, logistic regression, support vector machines, k-nearest neighbors, decision tree, random forest, and naive Bayes. Examples of unsupervised learning algorithms are k-means clustering, hierarchical clustering, db-scan, principal component analysis, and others. Choosing the right algorithm depends on the type of problem you are trying to solve. Some of the important reinforcement learning algorithms are Q-learning, Monte Carlo, SARSA, and Deep Q network. Now let's look at the approach in which these machine learning techniques work. So supervised learning takes labeled inputs and maps it to known outputs, which means you already know the target variable. Unsupervised learning finds patterns and understands the trends in the data to discover the output. So the model tries to label the data based on the features of the input data. While reinforcement learning follows trial and error method to get the desired solution. After accomplishing a task, the agent receives an award. An example could be to train a dog to catch the ball. If the dog learns to catch a ball, you give it a reward such as a biscuit. Now, let's discuss the training process for each of these learning methods. So supervised learning methods need external supervision to train machine learning models, and hence the name supervised. They need guidance and additional information to return the result. Unsupervised learning techniques do not need any supervision to train models. They learn on their own and predict the output. Similarly, reinforcement learning methods do not need any supervision to train machine learning models. And with that, let's focus on the types of problems that can be solved using these three types of machine learning techniques. So supervised learning is generally used for classification and regression problems. We'll see the examples in the next slide. And unsupervised learning is used for clustering and association problems, while reinforcement learning is reward based, so for every task or for every step completed, there will be a reward received by the agent. And if the task is not achieved correctly, there will be some penalty used. Now, let's look at a few applications of supervised, unsupervised, and reinforcement learning. As we saw earlier, supervised learning are used to solve classification and regression problems. For example, you can predict the weather for a particular day based on humidity, precipitation, wind speed, and pressure values. You can use supervised learning algorithms to forecast sales for the next month or the next quarter for different products. Similarly, you can use it for stock price analysis or identifying if a cancer cell is malignant or benign. Now, Talking about the applications of unsupervised learning, we have customer segmentation. So based on customer behavior, likes, dislikes and interests, you can segment and cluster similar customers into a group. Another example where unsupervised learning algorithms are used is customer churn analysis. Now, let's see what applications we have in reinforcement learning. So reinforcement learning algorithms are widely used in the gaming industries to build games. It is also used to train robots to perform human tasks.
Okay. So that's basically the concepts that drive machine learning. So as you can see on the right, so unsupervised learning, supervised learning, and then reinforcement learning are the three main aspects. So depending on what type of learning you want to go into, so those are the three main things when it comes to machine learning. Okay. So moving on to the next slide. So how big data and AI is producing smart applications. So basically, advancements in computer processing and data storage made it possible now to ingest and analyze more data than ever before, specifically during the pandemic, wherein there's a lot of contact tracing data. So around the same time, we started producing more and more data by connecting more devices and machines to the internet, streaming large amounts of data from those devices. So with more language and image inputs into our devices, computer speech and image recognition improved. Likewise, machine learning had much more information to learn from. Now, in the next slide, I'll also show a bit about, of course, big data and AI in producing smart applications.
The time of spreadsheets is over. A Google search, a passport scan, a barcode reading in a supermarket, your online shopping history, an EKG reading, CCTV footage, a photo of a sandwich, a voice message, a tweet. All of these contain data that can be collected, analyzed, and monetized. Supercomputers and algorithms allow us to make sense of increasingly larger amounts of information in real time. In less than 10 years, CPUs are expected to reach the processing power of the human brain. A survey done by the Global Agenda Council on the Future of Software and Society shows that people expect artificial intelligence machines to be part of a company's board of directors by 2026. There is a good chance that in 15 years, your job is going to be performed by computers, since decisions once based on experience and intuition will be made through machine analysis of massive amounts of data. Think about a vehicle that is able to read its environment and react accordingly, much like a human driver, but also analyzing other sources of information that will make the trip safer, faster, and more efficient. Analyzing vast amounts of medical data from different locations and demographics will allow to determine which conditions improve the effectiveness of certain treatments and which don't. Big data analysis will reveal patterns and connections that will vastly improve most human activities. But it will also create very detailed profiles for all of us, including information that we'd rather keep private. Will big data make privacy obsolete, or will it bring transparency, accountability, and progress?
Okay, so there you have it. So some of the applications on how big data and AI is producing these smart applications. Okay, now as you can see, the future is now. So AI's impact is really everywhere. Of course, so number one is transportation. So although it could take a decade or more to perfect them, autonomous car will one day ferry us from place to place. As you can see, of course, Elon Musk's Tesla can now do self-driving, self-parking. So in some cases, if you've watched the K-drama Startup, so there's like LiDAR that's being used already for like German companies are using it now to be able to really perfect an autonomous car. So the future is really now. Now for manufacturing, so AI powered robots work alongside humans to perform limited range of tasks, so like assembly, stacking, and of course predictive analysis sensors to keep equipment from running smoothly. So there are things like vibration analysis, wherein like for big factories, they can check if a machine is about to fail, they can now predict like if it will fail in a month, that you need to get it maintained. Because of course, like in super large factories, like predictive analysis is key in manufacturing, so that manufacturing will not be put in a halt, because like if it halts for about 30 minutes, like a lot of money is involved, or a lot of money loss is involved. So that's how AI is powering manufacturing right now. So in healthcare, so in comparatively AI nascent fields of healthcare, so diseases are more quickly and accurately diagnosed. So drug discovery is sped up and streamlined. So virtual nursing assistants monitor patients, and big data analysis help to create more personalized patient experience. So now in the pandemic phase, so there's a lot of monitoring with the clients, especially in the US, or like how they are able to quickly find a vaccine is because of a lot of things that are available right now in terms of data can be quickly churned with the use of AI, and even with the use of your watch. Like if you have like a smartwatch, it can check your BP. You can even set alerts on your watch, like if you have like high blood pressure or your heart rate is up, it can monitor, it can alert your doctor, so that if an ambulance is needed, it will go directly to your home. So those are the things that are really is prevalent right now. Even in the pandemic, like AI's future is very strong. Now, in terms of education, so a lot of textbooks are now digitized with the help of AI. So there's early stage virtual tutors that assist human instructors with facial analysis, so to basically check human emotions of the students, to help determine like if you're struggling or if you're bored, and better tailor the experience to their individual needs. And also with the use of machine learning, there's also things like detecting plagiarism now. So like if you submit like paper and then you just copied it and just put certain different parts with it, the same thing, so there are now tools that use machine learning to detect if you're cheating with your documents, or if you're passing documents that have been just copied and pasted from other documents. So that's how powerful machine learning is right now. Okay, now again, yep, so the future is now. So in terms of media, so journalism is currently also harnessing AI. So, and it will continue to benefit from it. So like Bloomberg uses cyborg technology to help make quick sense of complex financial reports. And of course, the Associated Press employs the natural language abilities of automated insights, so to produce 3,700 earning report stories per year. So basically what automated insight does is it gets from several different stories and then creates the stories that can earn them. So it basically is nearly 4 times more than in the recent past when it's just done by humans. Then of course, customer service. So of course, Google is working on an AI assistant that can place human-like calls to make appointments at doctors and at your neighbor hair salon. In addition to words, system understands context and nuance. And of course, in the day of the pandemic, customer service, because there's a lot of staff that are displaced and it's being replaced by chatbots. So as you can see, like if you have Globe, if you have like PLDT, so most of the time you're being now answered by a chatbot that gives you predetermined options. So that's an example of a weak AI, but nevertheless it's application of AI right now, especially during the pandemic, wherein companies are switching so that of course to protect their staff as well from COVID. So there. So are you guys still with me? Can you hear, or is everything clear on your end?
Yes, po, sir.
Okay, thank you. Okay, so let's proceed now to the next slide. So yeah, future is now. So this is how AI is going to change the world.
Lee is much more talkative about another threat posed by AI. He explores the coming destruction of jobs in a new book, AI Superpowers, China, Silicon Valley, and the New World Order.
AI will increasingly replace repetitive jobs, not just for have all displaced jobs, and we've gotten over it. The challenge of AI is this 40%, whether it's 15 or 25 years, is coming faster than the previous revolutions.
Yep, and I couldn't agree more. Like, especially during the pandemic, everything got fast forwarded. So, yep, so we really need to be able to adjust to the bandwagon. So, yep, so AI is really the future, and it's actually happening now. So again, so yeah, so the future is now. So AI's impact is everywhere. So one example, of course, is the current Google neural network, which is called DeepMind. So basically, Google has been very busy in the recent years. So having diversified into such field as, well, like the fountain of youth or anti-aging technologies, so medical devices, and perhaps, of course, for us, it's the neural networks. So the most visible development of Google's neural network research has been, of course, DeepMind, which basically it flags it at the machine that dreams. So it's the same network that produced psychedelic images everybody was talking about like a while back. So if you have a chance, like, look at Google's DeepMind. Of course, next one is the Facebook Chatbot. So as you can see, of course, if you're like a small company and you want to promote your business, of course, you cannot answer, like, there's a million people or at any given time in Facebook. So Chatbot is really one of the AI that's being implemented right now. So basically, any developer can create or submit a chatbot for inclusion in a Facebook Messenger. So this means companies with strong emphasis on customer service and retention can leverage these chatbots, even if they're like a tiny company with limited engineering resources. And of course, that's not the only thing Facebook is interested in. So again, AI applications are being used at Facebook to filter out spam and poor quality content. And at the same time, the company is also researching about computer vision algorithms that can read images to visually impaired people. So if you've watched again the K-drama Startup, basically it's very close to being a reality. Okay. So again, this is for what we call the smart assistants. So of course, in other parts of the globe, Alexa and Echo has been using natural language to control most of the devices at home. But again, like Mark Zuckerberg being wanting to be ahead of the curve, so he spent a year building what is similar to like Iron Man's Jarvis. So basically, it suggests that if Google and Amazon is successful in integrating their smart devices with many other home devices or proprietary versions, that Jarvis-like home AI would be available to anyone in the next 5 years. So basically, you have your Jarvis server, then you have any of the home systems, so your lights, your gate, thermostat, the doors, if you have like a Spotify, all the cameras, CCTVs, so on and so forth, microwave, air cons, and then of course with the use of AI systems, so you can do language processing, speech recognition, and then of course like face recognition, so that you don't need to open the door anymore. It will just look at your face from the camera, and then it will open your doors automatically. Okay. So again, last thing is of course the online shopping. So the key to online shopping right now, since we're in the pandemic, a lot of you are just the therapy is retail therapy. So online retailers actually are increasing revenue by helping you find and buy products you're interested in. So if you're doing Lazada or Shopee, so like they're taking it into a whole new level, because soon we may see retailers take it one step further and design your entire experience individually for you, like what you're buying, what do you want to buy. So like for companies like Optimizely, so they can create a digital experience for you. Like if you want to wear like shoes or clothes, so you can virtually fit clothes. Now with Lift Igniter, so content and product recommendations are personalized. So basically it's tailored fit to your buying preference. Like if you're into games, like it will recommend like skins or things that's related to your game. Or if you're like a what we call like a plant tita or into plants, so it will recommend like what type of plants and what prices and what's near your area. So basically that's being done by companies right now. So that's online shopping for, and of course like what I said earlier, like if you post something like you have a broken monitor, like in a few minutes you will see in your feed that there's like a broken monitor. And sometimes even if you're just talking, like if you have like a video call with somebody and you mentioned that I think I need a new iPad, even without even posting it, because of the natural language, later on you will see in your Instagram or in your Facebook or even in Lazada or Shopee that shows iPad 8 gig for sale or is on sale. So basically that's one of the things that personalized online shopping with AI can do or is doing right now, even in the midst of pandemic. So AI is very strong right now, especially when everything is really online. Okay, so this one is actually done in China, but yeah, I think it's pretty much there already. So one of the most interesting and of course disconcerting developments is at Baidu's lab, wherein the company calls Deep Boy. So it's a deep neural network that can generate entirely synthetic human voices that are very difficult to distinguish from genuine human speech. Basically, what happens is the network can learn and unique subtleties like the cadence, the accent, the pronunciation, the pitch, to create eerily accurate recreations of the speaker's voices. So basically, like it can mimic your own voice, or you don't know that you're talking to a computer and not or you're talking and not a human being. So that's the voice search that Baidu's doing right now. So let me just check, is everyone still here? Everyone's is it clear?
Yes, boss.
Okay, thank you. Okay, so there you go, like Baidu. Okay, so moving on to the next slide. So of course, I want to also share with you the current development tools that are being used right now for machine learning. Okay, so one of the top tools right now is the R language. So basically, the R language is used for visualizations, data analysis, and statistics. So it has libraries that are written and provide many statistical and graphical techniques like time series analysis, classical statistical tests, clustering, and classification, among many others. So the language is used to many basically to create high quality plots. These may include mathematical symbols and formula. So the R language. Okay, so the next up of course is Python. So Python of course is a language that is favored for its readability, and it's a relatively mild learning curve and functional structure that is used in many cases. So this language is beginner friendly and quite simple to use. So to use this language for machine learning, you do not even have to be knowledgeable in all the intricacies of it. So the Python machine learning is usually used in the model itself. Now, what are the tools that are being used for data analytics and visualization tools? So we have the Jupyter's Notebook. So basically, it's an application used in interactive computing. So it is a powerful and simple tool that used to tinker with data analysis problems. And this application allows users to write text description, of course, Python code, and embed charts and plots directly into an interactive web page. So another data analytics and visualization tools is what we call Pandas. So Pandas is a popular library used for retrieving and preparing data to be used later in other machine learning libraries. So it's basically reusable. So Pandas enables its user to fetch data from different sources easily. So it acts as a tool that simplifies analysis by converting, of course, JSON file, SQL file, tab delimited file, or comma delimited file into a data frame. So as you can see in the image below, so the collection of data and basically loading, manipulating, and processing and analysis is being done by Pandas, and then of course it converts it so that it can be evaluated by the model, it can be tested, and it can be used for training the model, and then you can provide predictions as an output. Okay, so another one of the data analytics tool and visualization tools that is very popular is the Matplotlib. So it basically is a plotting library for Python 2D. So plotting can be defined as visualization of machine learning data. So it allows the user basically to generate production quality visualization with just a few lines of code. So basically users can draw different kinds of charts and plots for visualizing results. So as you can see, there's a lot of different plots that you can use with a Matplot library. Okay, and of course the general machine learning tools that is out in the market, there is a Scikit-learn. So this is basically a library that's based on Python open source. So it's built on NumPy, SciPy, and Matplotlib, and supports classical supervised and unsupervised learning algorithms. So logistics and linear regressions, and the collaboration options, qualitative code, performance, simplicity, and ample documentation of plain language written to build upon its it's very popular following. So you have like the classification, so identify which category object belongs to. So we have the regression, so drug response, stock prices. You can do clustering. So there's where I mentioned earlier the customer segmentation, grouping of experiment outcomes, and then of course dimensionality reduction, so visualization and increased efficiency, as well as the pre-processing. So basically you can transform input data such as text to be used with machine learning algorithms that you create. So this is Scikit-learn. And then of course one thing is the natural language toolkit. So basically this is a platform developer for Python programs and enables them to decrypt human language. So it is recommended for NLP based tasks. So it's natural language such as speech tagging, text processing, and sentiment analysis, among others. So as you can see, like you have raw text, it segments it, so it tokenizes, so is it part of the speech, and then it can create like entities, like depending on what you're saying or what you're discussing about, and then it relates and then basically it segregates it into tuples. So like tokenize some text tag like 8 o'clock Thursday morning, and then from there you can now make sense of it, and then of course create a parse tree so that it will based on what you're requesting, it will of course output, or it will respond to the most near parse tree output based on your tokenized text or the language that you speak on. Okay. Now, essential open source data tools like Apache Spark. So, some bit about Apache Spark.
I'm a co-founder and chief technologist of Databricks, and I also started the Apache Spark project back in 2009 during my PhD at UC Berkeley. Today, Apache Spark is the most actively developed open source project in big data, and probably the most widely used as well. There are hundreds of people contributing to it every year, probably over 1,000 since the project first started, and it continues to rapidly add new features, new capabilities, such as libraries to do different types of analytics. What's unique about Spark at the highest level is that it's the only software framework that combines data and AI. So using Spark, you can do large-scale data transformations and analysis, and then you can immediately run state-of-the-art machine learning and AI algorithms on it. And that's super important for building AI products, because AI is only as good as the data that you put into it. It's powered by the data. And so when you have a framework that can do both things and that designs them to work together, you can quickly build the highest quality application. So at Databricks, I personally focus on a variety of topics just around our technical and product strategy. So with respect to Apache Spark, I'm always talking to users, trying to figure out, what are the issues that they're having with it, what are additional features that they'd like to see, and helping to guide the contributions from Databricks in these areas of the open source project. In addition, at Databricks, we're interested in building a unified analytics platform that's end-to-end, that goes beyond the analytics engine. So I'm also thinking all the time about the analytics process in general, how to enable enterprises and organizations to just reliably build data products as part of their business, and helping to design a lot of the key components of our platform that let our customers do that.
Yep, so one of the essential open source data tools is Apache Spark. So basically it connects your big data and then AI models. Okay. So next one, of course, is the meme SQL, or it's now single store. Basically, it's an in-memory database distribution platform. So it takes and analyzes streaming data and launches query on petabyte scale to support applications to work on real-time technologies like online games, community storage, and instant messengers, among others. Okay. So moving on now to the next slide. So another one, of course, is Pytorch.
Pytorch is one of the most popular open-source deep learning frameworks. Both researchers and developers use Pytorch because it provides fast, flexible experimentation and a seamless transition to production deployment. Pytorch is built to use the power of GPUs for faster training and is deeply integrated into Python, making it easy to get started. One of the best ways to get started with Pytorch is by going through the tutorial, Deep Learning with Pytorch, a 60-minute blitz, authored by Somit Chintala. Upon completion of this tutorial, you'll understand what Pytorch and neural networks are and be able to build and train a small neural network that can classify images. Keep in mind that this tutorial assumes that you have a basic familiarity with NumPy, a Python library for scientific computing. All of the modules in the 60-minute blitz have links to Google Colab, so you can immediately run code and get hands-on experience with Pytorch. You can also download the notebooks and run them locally. Now, let's take a look at the topics we'll cover in the blitz. The tutorial is broken out into 4 different modules. In the first module, What is Pytorch?, you'll learn the fundamental technical details of Pytorch, such as tensors and multiple syntaxes of operations. In the second module, you'll learn about automatic differentiation through a Pytorch package called AutoGrad. In the third module, you'll follow a typical procedure for training a neural network by defining the neural network, computing the loss, and propagating gradients back into the network's parameters. Finally, you'll get to put what you learned in the first 3 modules into a real-life example, training an image classifier to automatically label images. Let's get started.
Okay. So that's one of the products for neural network modeling is Pytorch. So let me move over to the next one then. So one of the things also is the Tensorboard. So Tensorboard is a tool used for graphical representation of varying aspects and stages of machine learning. So basically it helps you to see where the model components are located and be able to zoom in on any part of the schema. Like for example, you can use shoes, or there's like the schema, and then of course you can do a lot of it with tracking or visualizing metrics such as loss and accuracy, so profiling, displaying images, text, audio, so of course creating dimensional space, so like viewing histograms of weight, biases, and tensors. They change over time. Okay, next one would be another product, and you will see how it's being used currently in the industry right now.
Soprattutto documenti medievali richiede sempre molto tempo, molta pazienza. In Archivio Vaticano abbiamo 85 km lineari di documenti, più o meno la lunghezza del canale di Panama. Le scritture scritte nel Medioevo sono diverse da quelle che noi conosciamo. Se qualcuno mi chiedesse un giorno di trascrivere e tradurre tutti i documenti dell'Archivio Vaticano, sicuramente gli direi che è un matto.
Looking at this book, page by page, and trying to decipher, read and transcribe whatever is there takes an enormous amount of time. You would require an army of paleographers.
What I'm excited the most about machine learning is that it enabled us to solve problems that up to 10-15 years ago we thought unsolvable.
In Codice Razzi è nato da quest'idea di costruire un software per poter interpretare, per poter leggere quello che è scritto dentro i manoscritti. Quando abbiamo iniziato ad approcciare il problema ci siamo resi conto che una soluzione basata su reti neurali fosse assolutamente necessaria. La scelta su TensorFlow è stata abbastanza naturale.
Before using any kind of machine learning model, we needed to collect data first. You have thousands of images of dogs and cats in the internet, but there is very little images of ancient manuscripts. We built our own custom web application for crowdsourcing, and we involved high school students to collect the data. I didn't know much about machine learning in general, but I found it very easy to create a TensorFlow environment. When we were trying to figure out which model worked best for us, Keras was the best solution. The production model runs on TensorFlow layers and estimator interface. We experimented with binary classification with fully connected networks, and finally we moved to convolutional neural network and multi-class classification.
In poco tempo siamo riusciti a sviluppare e a testare le prime soluzioni.
When it comes to recognizing single characters, we can get 95% average accuracy.
Poter accedere a uno strumento informatico abbrevia notevolmente. Sciogliere certe abbreviazioni, comprendere un testo in quella scrittura così criptica è un qualcosa di eccezionale.
This will have an enormous impact. In a short period of time, we will have a massive quantity of historical information available.
I just think solving problems is fun. It's a game against myself and how good I can do.
Lo studio della storia è importantissimo per comprendere il nostro presente e per avere anche una prospettiva per il futuro.
So as you can see, it's very exciting times that we live in. Like for example, in paleontology, like the archives in the Vatican, so they're using neural network modeling or machine learning, and like one of the products is TensorFlow, that basically is a leading framework for all types of machine learning tasks, wherein of course they can now digitize those scriptures or manuscripts, which basically it's a lot. So there's a lot of applications to be excited about in terms of the possibilities in machine learning and in AI. So I hope you guys are appreciating the value and, well, the times that we're living in, wherein these are all now possible with the use of machine learning and AI. So basically for this one is, what's the next industrial revolution is AI and ML.
Put yourselves in the shoes of an early 17th century human. The industry then was extremely slow. Workers had to craft items from hand, and mass production didn't exist. To workers of that age, today's world would seem magical. For them, a 50-story building would be impossible to make. What changed between the 17th century and today is machines. The Industrial Revolution allowed us to build products at faster rates we had ever seen and allowed us to scale up our creations to sizes never possible before. Skyscrapers, massive ships of steel, cars, and the furniture in your home, as well as the systems derived from them, such as the shipping industry, transport across hundreds of kilometers in a day in cars, and the buildings you have grown accustomed to, seen daily, are all possible because of the Industrial Revolution. What the Industrial Revolution did was remove the physical labor from human hands. Not bound by our bodily constraints, we now have machines, like cranes and cars, that could lift weights hundreds of times heavier than us. They help us achieve things with their immense physical strength. Artificial intelligence has been hailed as the next industrial revolution. People think they will change the world by providing smart solutions. Everything solved by AI. Customer service? Replace that with a bot. Data analysis? Replace it with unsupervised learning algorithms. Cashier? Replace it with Amazon Go. All people can think of is how AI can solve existing problems. What they don't understand is that it will solve problems that we didn't even realize existed.
Yeah.
We must stop thinking of AI as only solving current problems or slight variants of them. An average 17th century man did not know that he wanted a 50-story building or a machine that would allow him to travel 100 kilometers per hour. Henry Ford is known for saying, "If I had asked people what they wanted, they would have said faster horses."
Yeah.
Instead of thinking of improvements to current systems and industries, think of completely new industries AI has the potential of creating, for it is the products that create new industries that do the best. Artificial intelligence has the capacity of understanding so much more than we do. The barriers of seemingly incomprehensible theories of science will be broken easily by the machines of the future. Physical problems, like we solve thousands of times faster than humans could, not only AI will optimize many of our systems, but also create new jobs. We don't know the rate at which it will do this. However, research firm Gartner further confirms the hypothesis of AI creating more jobs than it replaces, by predicting that in 2020, AI will create 2.3 million new jobs while eliminating 1.8 million traditional jobs. Just like AI took away the physical constraints of humans, AI will be able to take away our mental constraints. Just like machines whose strength is hundreds, if not thousands of times stronger than us, AI's intelligence will be hundreds, if not thousands of times smarter than us. But after being liberated of both hard physical labor and mental work, what will humans have left to do? What do you think are the most fantastical things yet to be solved by artificial intelligence? Thank you for watching.
Okay, there. So yes, you can see we now live in times wherein AI and ML is really the next industrial revolution. So even as we speak, there are a lot of different cases or a lot of different uses of AI and ML, especially during the pandemic, that are really fast track and really right in the now. So yeah, we're living in very exciting times, and yeah, I'm truly honored to have shared this information with you. So I think that ends my presentation, and of course I'm open to any questions or any clarifications that you might have, and I do hope that you are enlightened with the power and the possibilities that AI and machine learning can bring, even during this trying times of the pandemic.
Sir, there's one question from Miss or Mr. Oluwa Sola. Do you think the progression of AI is anti-poor? If no, how so? If yes, what do you think the government, what do you think the government should go about pursuing AI advancement?
Okay, well, thank you for that question. Now, the thing is, of course, just like with any other revolution, it will be said that it is anti-poor, but eventually, if you try to improve yourself, you will not be left by the bandwagon. Like, of course, others that are building railroads when the steam engine was built, so a lot of the people, it created more jobs than it will lose. A lot of I think it will create more jobs than or opportunities for others that would be willing to go and explore and of course improve themselves. Now, in terms of the government, that's something that I think on my level I cannot answer as much as I want. I think I can provide a theoretical answer that, of course, in any other government in the country, we should pursue AI advancements, because like a lot of the private sectors are doing it, but really the government is really left behind. So there's a lot of automations that we can do, like in other countries where voting is automated, where we can just of course we don't need to go in lines to get government services. So those are the things that maybe the government can look at, but of course since I'm not in the government, I can't really comment on that one. But I do hope I answered your question, Oluwasola.
With all these developments and innovations that are happening in AI, some are really overwhelming and too many to master,
Yes.
What's the future for fresh graduates of IT in this field? Meaning, what kind of preparations or training do they need to have a chance of landing a job in this field?
So I think one of the things, of course, there's like the data analyst or the data scientist route. So, but of course, you have to have your love for math, because a lot of this are really based on algorithms, discrete math, or statistics, to be able to be in this industry. So that's one thing that you can do. Another one, of course, is you don't need to do the math, but you can do development. So like I've shown in the videos or in the tools, like there's a lot of tools that you can learn off the shelf that are free. So you just have to go download it, set up, and sometimes there's also like virtual sandboxes wherein you can test your actual code. So like the R language or Python, those are readily available to any one of the students that are willing to go out and learn it. And then there's the different pre-open source tools out there, so that if you want to go into this career, you can. And of course, like what I keep telling fresh grads, or you can also make your own career. Like you don't even have to go to work to a company. You can create your own products. Like some of the people that I know that are successful, even if they're young, so they created their own opportunities. So they learned, they created their own opportunities. So that's one of the exciting things about IT. It's basically limitless. So it's only, you are limited only by your own will and attitude and imagination. So I hope I answered your question, Ma'am Lori.
Thank you, sir. Thank you, sir. What can you advise our students, Sir Chris? No, how bright is the future that awaits them in the work arena?
Yeah, actually, well, the future is very bright. As you can see, like, well, you can go in different routes. You can come work for a company, or you can start something on your own. So the possibilities are really limitless, especially in the IT field. So my only suggestion is, of course, if something goes wrong, or if you fail, it's okay to just stand up, shrug it off, and learn. So, but of course, there's other things, like if you want to go into the quality space, like you want to be a QA or quality analyst, that's also fine. And of course, like with machine learning and AI, you can be a data scientist or a developer as well, for developing the models that are being used in machine learning. So there's a lot of different possibilities out there, and really the future looks bright. But of course, you have to have the right attitude, and you have to be able to dream it. So in some of the companies that I go into, really hindi ko alam kung ano yung ginagawa nila, but when I come in, I learn about it. So I think my passion for learning is what kept me to where I am now, because like I've been to like very big billion-dollar companies. I've worked for them. I've been a boss. I've been an employee. Like, I started from the bottom. So yun lang, kailangan you have to be patient, you have to be humble, and yung passion for learning mo should not stop. So yun, that's I think the future is very bright for everyone on the call, and I think you just have to go in and grab it. Be humble, and always learn to communicate and learn to listen. So those are the tips that I can give to you guys. But yeah, to answer your question, man, the future is looking great for you guys, especially that everything is fast forwarded right now. So like things that should be done like in a couple of years are now being done now. So you just have to go in and grab it.
In behalf of the College of Engineering and Information Sciences, we would like to thank you, sir, for sharing your most precious time with our students. I'm sure that they learned a lot from the session. It's a very comprehensive discussion, sir. And those things that you mentioned might be big words for them, but I'm sure that after graduation, when they join the workforce, that's when they would realize, these are the things that Sir Chris mentioned to us during our seminar. Thank you very much for gracing this afternoon's event.